Hello, everyone, and welcome to Building SaaS on AWS. My name is Gunnar Girosh. I'm a developer advocate here at AWS, and this is our weekly show where we talk all things about building SaaS on AWS. I usually bring on experts on every show to talk about specific SaaS topics, and of course, we have guests on this week as well. But if you're new to the show, well, what we do is we dive deep on SaaS specific topics to learn more about what it's like to build SaaS on AWS. And we want to make it interactive. So if you have any questions, any comments, just drop them in the chat. And I guess with we, I mean my guest, will do their best to answer those questions. So this week, I'm super excited to be joined by first a returning guest, Farouk, colleague from AWS, but also by Jay and Sean from Hashicorp. Welcome to the show, all of you.
Thank you so much. Great to be on.
Thanks.
So let's do the quick round of introductions. Let's start with you, Farouk, as a returning guest. Welcome back.
Thank you, Gunnar. So I am a solutions architect at AWS, and I support customers in the SaaS space across various industries.
All right, welcome back. Sean, you can go next.
Hey everyone. I'm a senior solutions engineer at Hashicorp. I support our partner and channel alliances. I'm happy to be here, and look forward to the session.
Great to have you, Sean. And Jay.
Thank you so much. It's a pleasure to be here. My name is Jay Aware. I'm a solutions engineer here at Hashicorp, specializing in our security line. And I work with a variety of customers across many different verticals, from the private sector to public sector. And it's a pleasure to be here.
All right, great to have you all. And of course, we usually have a bunch of SaaS experts in the chat as well. And if I'm not mistaken, I think we have Anthony with us today in the chat. So there to help answer any questions as well. All right, like I said, we always have specific topics on each show. And this week, we're going to talk about dynamic data isolation. And of course, with Jay and Sean here, it's going to be around Hashicorp Vault. So a common question that we get when we talk on this show and we hear from developers is, how do I isolate tenant data in the cloud? And as we know, tenant data isolation, that's core part of SaaS, software as a service. So Farouk, maybe that's where we start. How do I isolate tenant data in the cloud?
Exactly. So this is where we have been working on this solution to provide a mechanism for isolating tenant data, particularly in a multi-tenant environment, where data could be commingled together from various types of tenants, various tiers of tenants. And we basically follow a pattern which has become somewhat popular lately, which is called a token vending machine, or TVM for short. And this solution is, in fact, an implementation of that TVM pattern. And what we target to do is overcome some of the challenges that we will be discussing shortly, and how do we address those challenges in the solution.
Right. And part of the discussion now, or I guess maybe the core of the discussion, that's a blog post that you have created together,
Correct.
I believe.
Yes. Correct. Yeah. So this was the work that we started with, and then that blog post has evolved into some of these sessions that we're doing. Some are live, some are offline.
All right. So yeah, Farouk, maybe you can start us off with then getting into it.
Sure. So we will first look at the challenges that we considered while developing the solution, and then we'll go a little bit into the architecture, and as a follow-up, we will do a short demo towards the end of our session today.
Demo, super important for our viewers, so I'm super excited to see the demo later on.
Absolutely. We're excited too. All right.
All right. So yeah, let's get to it.
So in terms of data isolation, as you mentioned earlier, it is top of mind for a lot of developers, a lot of SaaS providers. How do we isolate data, and what are some of the challenges? So we start basically with the platform that a lot of our customers have chosen as as the foundation for building their SaaS solution, which is EKS, or Elastic Kubernetes Service, which is essentially a managed Kubernetes service by AWS. There's significant growth in the adoption of EKS as a platform for hosting SaaS solutions, which brings a number of challenges that we're trying to address in this solution. Along with that, we have the challenge of injecting credentials dynamically into your application microservices that are running on the Kubernetes platform. That's also a significant challenge. Traditionally, various approaches have been adopted by developers, to generate those credentials or get those credentials within their application code. What we're proposing to do is sort of separate that and decouple that from the application and generate it separately, by essentially bringing in a model where we can separate credentials management from the application logic. And along with that, so what we target to do is essentially improve the efforts and the time required to do compliance and security controls. And along with that, this mechanism basically improves your velocity of getting the credentials from a trusted source, and also managing the life cycle of those credentials. And along with that, we provide separation of concerns, so between policy enforcement and data access. So you could have clearly separate roles that manage policy enforcement and roles that are actually going to access the data.
And Farooq, you mentioned a token vending machine. Can you maybe give a quick introduction of what a token vending machine is?
Exactly, yeah. So token vending machine is essentially it's captured in this third icon, so to say, on my screen. So basically it provides a mechanism to isolate credentials management from the application logic. So it's a piece of software that is running independent of your application or your microservice, and it manages credentials, retrieval of credentials, lifecycle of credentials, and so on and so forth. And all it does is it serves those credentials to your microservice in a very simplified manner, where the application does not necessarily have to do the heavy lifting of managing those credentials. It simply just reads those credentials and uses those credentials to access data. And we will see a bit of architecture as we go forward. So with that, I think we can go into a little bit of the high level of this solution, a description or an architecture of the solution. As you can see on the right-hand side of this diagram, where your microservices or your application is running, and the entire left side of that is the token vending mechanism that we talked about. And that token vending machine pattern that we talked about, here we're implementing it using Hashicorp Vault, which has, in fact, two components. One is the server component that you see as a bigger triangle, and there's a smaller component, which is the Vault agent, which you see as a small triangle on the right side. And that's the component that sits essentially next to your microservice or your application. And in this specific case, when we're using EKS or Kubernetes, it is sitting next to your microservice as a sidecar container. And that basically helps the microservice read credentials from the central Vault server and serves those credentials in the form of AWS credential files, which the microservice can read and use to access the data that belongs to a specific tenant. And this is a very dynamic solution, in the sense that for every request, this solution is going to retrieve credentials specific to a tenant who's generating that request. So it is very dynamic in that sense. And you can imagine, at any moment, a microservice could be running multiple threads, and in each thread it could be servicing a different tenant. So it is able to handle that sort of scenario and retrieve those credentials and handle them in an isolated fashion.
question for Jay or Sean maybe then, but how does Vault provide this token vending machine functionality?
Great question. So, and I think we're going to touch on it in just a few more slides, but fundamentally, what we're going to have is, with the architecture, we're going to have a main Vault server that does the actual credential management, generation of those credentials. And then we'll have a sidecar container within the Kubernetes environment. So almost like an injector, right? And that transparently provides those credentials to the application. We're going to look at what that workflow looks like. It's not as simple as I'm describing it and keeping it at a high level. I promise it is more secure than I'm describing. And fundamentally, it's a very seamless process. Ultimately, we want that developer workflow, the application workflow, to be as seamless as possible with minimal or zero disruption. And this is the way that's achieved.
All right. Farouk, please continue.
Right. Yeah. So I think we're going to talk a little bit about how EKS and Vault together are providing a solution that is a strong zero trust solution. And I would invite Sean to talk about that, being an expert on that subject.
I can take over, just continue on the track that we were in. So, what the fundamental reason, why we would want to use something like Hashicorp Vault together with EKS, right? It's because there's nothing else better together. So Vault is that zero trust centralized secrets management solution. What does that mean? That means, we don't necessarily, one of the Vault taglines is trust nothing. Authenticate and authorize everything. So that inherent trust that we used to think about within on-premise environments, that doesn't exist in cloud environments within cloud environments anymore. And we're gonna keep that paradigm alive, right? And the next capability, or I would say value, that Vault provides within this solution is dynamic short-lived credentials. So that allows us to move away from the legacy long-lived credentials that may be rotated once every 90, 180 days, if at all. And that makes me, so I have a background in security, that makes my security engineering side a little bit more relaxed, less anxious. We're rotating credentials, they're short-lived. So if they accidentally get checked into, a code repo or something, that's okay. We can easily revoke them. They're short-lived. And again, I think I touched on this a few seconds ago. We want to make this as transparent as possible to our environments, applications, consumers, and developers. And so with Hashicorp Vault and its agent technology, we're not going to need to refactor any application code. There's no rewrite that's needed. The application continues chugging along, receiving the credentials as it's used to doing. And what's great is we'll share some links out at the end, so you can get started right away. But Vault comes in a couple different flavors. So it comes in open source, free flavor, as well as an enterprise version that provides enterprise capabilities, things like FIPS 140-2 compliance, governance, as well as HA and DR capabilities.
Right. Farouk?
Right. So let's dive a little bit into the architecture of the solution. So we're going a little bit more technical, and then I promise there isn't a lot of slides. There's only 3 of them. We'll spend a few minutes talking about the architecture, and then we hope to dive into the demo part. So in terms of the architecture. So essentially, I'm not going to go into the details of how to deploy an EKS cluster and the remaining ecosystem. That is something that we demonstrate in our blog post, as well as the source code that we share along with that in our GitHub repos. So I'll skip that part and focus on the core pieces of how we deploy Vault and the surrounding systems that are going to support the solution. So in EKS, we first deploy a Vault namespace where we're going to deploy the Vault server pod, which is part of a Helm chart that can be that can be called and run, and that automatically deploys the pod. Then we have, along with that, the tenant namespace. So there's going to be potentially a namespace for each tenant in case of, again, we're going to talk about the models between silo and pooled tenants. So they could be a silo tenant, which is dedicated to a specific tenant, and a pooled tenant space where you could have multiple tenants accessing that application in the same namespace. So either ways, it's going to be a separate namespace where we're deploying the application in a separate pod. And along with the application, we're deploying this Vault agent sidecar. That sidecar basically sends a request for credentials to the Vault server. What the Vault server does is it reaches out to AWS STS service and generates temporary credentials, which are returned back to Vault server. And Vault server also caches them in its secure local storage. And then it can manage the life cycle of those credentials as well. So as they expire, it can either completely remove them from the cache, or it can renew them based on the policies that you apply on the Vault server. And then those temporary credentials are returned back to the Vault agent sidecar, which it presents in the form of files, as we mentioned earlier, the AWS credentials files. And those files can be read directly by your application microservice. And once the credentials are there, it can go out to a database of sorts, or some data persistence layer. In our case, it's an Amazon DynamoDB table. So it is going to access some elements from that DynamoDB table using those credentials.
Yeah, one thing I think is important to point out here is this is the flow after the sidecar has been authenticated. So also we're pointing out the a specific secrets engine in Vault. Vault services multiple secrets engines. So this is sort of that secret engine flow after the sidecar has been authenticated. Vault will check its policy against what that sidecar what the Vault agent can read. In this case, it's reading from AWS STS, and this is the flow that occurs. So just that clarity there.
And what is the main reason for using the Vault agent?
This is to Jay and Farouk's earlier point, where with the Vault agent, it can write credentials such that the application doesn't need to change its code. The Vault agent presents credentials from Vault back to the tenant, and the tenant can then consume those agents through syncs. So the Vault agent writes to a sync. The application just looks at the sync for the credential, and then can go and authenticate. So in this example, we're using what's known as the auto auth agent. That's a sidecar. We actually just released, and it's in beta, but we just released a native Kubernetes secrets integration, so that we can put these secrets straight into Kubernetes secrets as well. We'll provide a link to that after the show for that as well.
Yeah, I would just add that this could be considered as a no-code way of presenting and consuming credentials, so where your microservice does not need to have a piece of code there to retrieve or access credentials, except just to read them from a specific location within its pod.
And I know for this episode and for the blog post, the focus is on EKS, but could you do something similar then on, say, EC2 instead, if you're running instance-based?
Yep, you absolutely could. So whether it's EKS, EC2, or even Lambda, Vault is what we know as platform agnostic. It doesn't care where it lives, what it interacts with. It has an extensible API as well as agent capabilities and a command line interface. And so no matter where the environment is, what the environment is, even in my home lab, I have Vault running on a Raspberry Pi cluster. And so Vault can live and breathe and deliver those credentials securely in any environment.
Right. So everyone, if you just joined us, this is Building SaaS on AWS. I'm Gunnar, today joined by Farouk, and we also have Jay and Sean from Hashicorp joining us. And we're talking about dynamic data isolation using Hashicorp Vault. So is it finally time to dive into a demo, maybe?
Before we do that, I just wanted to kind of provide a little bit of distinction between how we handle silo tenants versus pool tenants, because there is a slightly different mechanism in pool tenants where you're presenting multiple credentials to your microservice, because you could be expecting any of those tenants to be landing on that microservice and requesting data. So just wanted to give a little bit of perspective on that, and then we can move to possibly to the demo.
Right, let's do it.
Sure. So for silo tenants, we basically we deploy the Vault engine that we just talked about a little bit ago, and along with the Vault engine, there is another component that we deploy, which is called the Vault agent injector pod. So this is an agent that detects the deployment of tenant pods, which have certain annotations. And once those annotations are detected, it is going to deploy a Vault agent automatically into that pod. So what we are doing here is providing the automation where the developer or the end user does not necessarily need to worry about this automation. They just deploy their application, and the ecosystem detects that and deploys the necessary components that are going to handle this this entire mechanism. So the Vault agent injector deploys the Vault agent automatically, and along with that, it deploys the necessary Kubernetes constructs as well. So the configuration for the Vault agent, as well as the secrets that it needs to communicate with the Vault server. Those are two additional components that are deployed by this injector pod. And once that is there, it follows the same sequence that we talked about earlier. It reads credentials from Vault, and then it presents them as AWS credentials files to the application. And that's basically for a single tenant in that namespace. So that credential is going to create a single credentials file and share it with the application. In case of a pooled tenant or a pooled set of tenants, it's going to be slightly different. Even though the infrastructure is going to be the same, you're still going to have the Vault server, and you're going to have the agent injector pod. It'll still do the same thing. But what we have is on the tenant pod, we have a bootstrap sidecar or an init container. What it does is, when this pod starts, or let's say restarts after an issue or a problem, it basically goes to an S3 bucket and brings down some templates from there. And these are templates that define basically what are the different tenant credentials that we're hosting on this pod. And we'll see some examples of this during the demo. And based on these templates is going to, the Vault agent is going to present those templates in credentials files on that volume. And as you can see, this bootstrap or init container has its own identity as well. So it needs IAM permissions to access that S3 bucket. So it has its own identity also associated with that. And what it does is it reads that template, it copies that template into a local volume that is mounted on that pod. You deploy your application. The Vault agent injector detects that. It is going to launch the Vault agent into that pod. The Vault agent is going to read the template file and detect what are the different credentials that it needs to retrieve. And instead of retrieving a single credential, it's going to read multiple credentials from the Vault server, and is going to bring them back and present them as multiple credentials files. And again, the mechanism for the application to access those credentials file is the same. And the approach we have taken in the solution is to name the credentials files based on tenant IDs. So the application, when it receives a request, it just retrieves the tenant ID from the context that it receives along with the request. and it simply needs to read the file on a specific location with that tenant ID name, and it has access to those credentials. So that is the slight twist in the pooled model versus the silo model. And that kind of concludes our presentation, and we are ready to jump into the demo.
Very cool. All right. So thank you, Farouk. Sean, I guess you're up.
Yeah, yeah, absolutely. So let's dive in. So what we have here is we've already set up sort of the base infrastructure, and now I know we've been talking a lot about Vault, but we actually use Terraform, which is another Hashicorp product, to set up all of the infrastructure using infrastructure as code. This is really great because when we were building this, it allowed me to iterate on it and not necessarily leave it up and standing. I could iterate, tear it down when I'm done, iterate again until we get to a good spot. So we built everything with this, spun it up before this demo, just the base infrastructure pieces. And it consists of many different AWS constructs. So we have an EKS cluster. We deployed Vault on the EKS cluster. And one thing we didn't mention here is we're showcasing this. Since this is all about security, we're actually showcasing this as a private EKS cluster. So it has no internet access. We're sort of using Cloud9 here as a jump box of sorts. Terraform actually pulled 3 different images from the internet and pushed them up to ECR, and that was all handled through Terraform. And so the cluster itself is completely private. We're using VPC endpoints to access it and things like that. We also use the Helm provider in Terraform to deploy Vault on the cluster. So with that all said, let's take a look at the cluster itself here. Go here. So just take a quick look at the Vault namespace. So you can see the Helm deployment deployed Vault, and Vault isn't not ready. And that's an important thing to point out. So Vault starts in a sealed state. We have to actually initialize Vault. And this is a long architectural topic, but short form is that we need to construct an encryption key that can decrypt an internal key ring inside of Vault. So Vault starts up, it can't read its own storage. It starts in a sealed state. It needs an external key to be able to read that storage and function. So that's one of the nice things securely about Vault is it has this ability to seal and unseal. There's 2 different ways to do that. Again, not going to get into the details of that. For this example, we're using auto unseal with KMS. So we deployed a KMS key that has this capability. So with that, we're going to go ahead and initialize Vault, and I'll do that now. And so what we're doing here again is we're saying Vault, hey, we're ready to utilize you. So we're initializing and unsealing Vault, and you'll notice we're putting some of these keys for purposes of this demo. We're putting these keys over into Secrets Manager for safekeeping, and we enabled 2 things, right? So Vault has 2 major components. It has secrets engines, which we talked about. In this case, we're using one specific secrets engine for AWS, and it has authentication methods, and that's how the Vault sidecar or a NIC container is going to authenticate the Vault first to be able to utilize those secrets engines. Oh, one important thing to point out, and maybe I will show this from the console. So we have a DynamoDB table, and we're going to be using this as an example to showcase how Vault is able to just scan expand this table real quick. Okay, yeah. So we have different items in this DynamoDB table, and this is what we're going to use to showcase. Tenant A can read tenant A's data. Tenant B can read tenant B's, etc., but not tenant C's, etc. So just wanted to point this out. This is what we're going to be using as sort of our test access here. So let's go ahead and we're going to deploy our siloed tenants. And please, Gunnar, at any time, if there's any questions, just let me know and I'll be happy to answer them.
Oh, yes.
So this is moving kind of fast. We'll go back and take a look at what we're doing here.
So while that's running, I know Sean just mentioned the individual tenants being able to only see or consume their respective areas within the DynamoDB table. And so that's that authentication and authorization piece that I alluded to earlier along with Farouk. So the very first thing Vault does is authenticate the identity, whether it's a human user, whether it's an application. It can do that via simple tokens. It can do that via SSL TLS certificates. Once that's authenticated, Vault will evaluate that action, what it's trying to do against a set of policies. Vault's designed as a default deny policy set, so we can specifically only allow, that makes it more pragmatic, more purposeful into what we allow access to. And that's what we're going to show here, the applications being authenticated and authorized to be able to access what they need to consume. And then we're also going to show a few test cases where they can't access things there that are not permitted within the policies.
Yeah, thanks, Jay. So taking a quick look here, what just happened, right? Because that moved sort of quickly. So we wrote a new role for two different tenants, tenant A and tenant B. We're treating these as siloed tenants, so they're the only thing running within this pod. And you can see here, there's many different options that you can set on this secret engine. The main one to point out that we kept it a little simple here. The main one to point out is we have a policy document here, very similar to AWS IAM policy, right? And we're specifically setting conditions here for this tenant to just be tenant A. But don't get confused. This is the same syntax. It's not the same policy or the same, right? This doesn't map directly to a policy. It maps to a base role that we're going to use, but we're not using Vault to edit IAM. If I went into AWS IAM, I would, this isn't controlling one for one that policy. It will write roles that these tenants can use, but I just want to make that clear because sometimes it's a little confusing. Like, this is a policy that we define within Vault.
Yeah, just a clarification here. So essentially what Vault is doing is it's calling assume role APIs of STS on behalf of those tenants. And it is using this policy that we're defining for that tenant as a session policy that helps it generate tenant scope credentials, which are temporary in nature.
So it's assuming a role, then the calling STS to get those credentials. Is that the case?
Correct. Yeah. So it's using the assume role API along with that policy that we set as a session policy, which is scoped to that specific tenant. Yeah. STS returns back the temporary credentials for that tenant, which Vault just stores in its local encrypted storage.
Correct. Now we can set TTLs on all of these. So once Vault goes and gets it, there's two concepts. There's a renewal TTL and a max TTL. So Vault can renew the TTL. Vault can renew the TTL up to the max TTL, and then after that, it needs to fetch a new credential. And that's all configurable. We can do that through here. So let's take a look at what that actually deployed. We're just going to look at one of the tenants in this example for purposes of time. We can see here we have a pod. It's got two containers. One of those containers is describe on the whole thing because it's.
We have a question on what we just talked about, so let me just bring that up from Robert Tables. So the actual enforcement of the roles access is controlled by AM, but granting the ability to assume a role via STS is handed over by Vault. Is that correct?
Yep. Yeah, that is exactly true. So Vault is assuming the role, it's getting the credential, and then handing it over to the Vault credential, or essentially to the end microservice that needs those credentials.
Perfect. All right, thanks for the question, Robert, and let's keep the questions for our guests coming.
Yeah, great question. Great question. So you can see here we have two containers within this pod. We have my app, which is the actual tenant, and then we have the Vault agent that's running. So that's why we see 2 out of 2 pods here. So again, just a quick overview of some code. I have them up here. So we have a secret here that this, well, actually, I guess first let's look at this deployment. So here's the deployment of the Vault agent example. And as Farouk and Jay alluded to, we have various annotations that the Vault agent and Vault injector look for. And so in this case, important ones to call out here is agent inject is true. So that's telling the injector to inject the Vault agent into, in this case, into this namespace. And this agent config map, this is an agent extra secret. These are 2 critical pieces. So the Vault agent, as we mentioned, needs to authenticate to Vault to retrieve a token through that token vending machine model. That token has certain policies assigned to it that allows it to do actions within Vault. So getting the token is the first step, and then the agent logs back in with the token and says, I want to do X, and the token Vault looks at the policy assigned to that token and then says, okay, you're authorized to do X. Here you go. So this is the config map that the Vault agent is reading, and this is telling you how Vault's going to authenticate in, right? So we're gonna use AutoAuth with the injector agent. The method or the authentication method we're going to use in this case is app role. And for more details about app role, please see our website. I'm not going to go over that in this discussion, but it is a method to authenticate to Vault. We have multiple methods to authenticate. It's going to write that token down it's going to write the token down to a sync file, and then the injector agent is going to use that token again to authenticate the Vault to then fetch credentials. In this case, we're using this template method here. So you can see we specify a destination to write those secrets. And then we actually use this to go through and fetch the secret data from Vault for the application to read. So the application itself just needs to know the secrets are in this location, and you can set up that secret store to have whatever format you need. So to see this and to see the results of this, we're going to shell into tenant A.
And while that's running, just wanted to kind of expand on some of the capabilities we saw, configurations we saw within the Vault agent config. And so we saw an example of path-based sync, right? So Vault will dump that credential into a certain file path, whatever it might be. But what if we don't allow that based on security guidelines or requirements, or we have some other method of accomplishing it? So Vault has multiple sync capabilities. So it can present the credentials to the application as environment variables. It can do it based on a credentials file. It can even dump them out to a CSI, a container storage volume that might exist just for the application container itself. So there's a variety of ways to get that credential to the application rather than being limited to only path-based methods.
Yeah, absolutely. So we're shelled in here. I'm just going to set that we want to test tenant A. So that's the profile we're going to use. So if we try to read some data from Dynamo, I'm just going to read this first item. So we can see that we can read this data back. If we try to get something else that belongs to another tenant, again, this is due to the policy that Vault has assigned. We get access denied. So Vault has effectively given us a credential back to read this table, but only read items, shard items that belong to application A. All right, so
then can we summarize the mechanisms that Vault uses to isolate tenants? We had the roles as a way to isolate tenants. We also saw policies, right?
Correct. So the policies are tied to the role. So when we utilize, and different secrets engines have different paths. So in Vault, everything is a path. But essentially, we control access. We control what actions a token can have on a path, and then assign a policy to the. We define a role. So in this case, we're using the AWS secrets engine. As we can see, if I scroll way back up here.
Yeah, I just would like to add one point here. Right? So Vault is sitting in between the application and STS or IAM. So Vault is dealing with two different roles. One is the IAM role that Vault has to be able to call STS and retrieve credentials and so on. And also Vault has its own internal role mechanism. So it can create various types of roles. And what we saw exactly is a role that is created for the Vault agent, for the agent to be able to retrieve specific credentials. So there are two types of roles at play when we're talking about this specific solution.
Yeah, that's a great point. Very important to make that distinction. So, but yeah, so you can see here the role for tenant A allows these various key settings, these various configuration settings, and again, that right here we're defining, just as Farouk mentioned, sort of that isolation technique here. And then the last piece is, again, TTLs, right? The dynamic nature of this. So we can, by default, we would get back a certain TTL from AWS IAM, but Vault can have shorter IAMs like that. Like if our pods only need to have this secret for 10 seconds, we can set that as a TTL for 10 seconds. Now with the Vault agent, if the pod needs access again with auto auth enabled, the Vault agent will go out and fetch a new credential, but that's the thing, it'll be a new credential. Right. There's more advanced use cases with Vault that you can get into with wrapping tokens, and in that case, it's not only is it TTL based, but it's also one-time use based. So if that secret gets used, it can never be used again. You'll have to fetch a new one. But we don't cover that in this example specifically.
Yeah, and another important capability that Vault brings here is that if you're talking directly to STS, you could generate tokens which are valid for anywhere between 15 minutes and I believe 12 hours. And once you generate a token, you actually cannot expire that token. It's going to expire on its own. So that's one sort of a capability that Vault brings in, that you can expire those tokens within Vault, and those tokens will essentially disappear from Vault, even though they will exist in STS, but they will not exist in Vault. They will be removed. So application will not have access to those. If you have, for example, some leakage that happens, you could basically disable those credentials.
Yep, and just to kind of expand on that very quickly, we mentioned TTLs. Farouk just mentioned how those, what happens when those credentials expire. Under the hood, what's actually happening is Vault is revoking those credentials, right? We can call it disabling, but fundamentally it's revoking them, and so. And it does that immediately. There's no, I'm going to mark this for a revocation and it'll be effective sometime in the next 30 days or something like that. It is absolutely immediate. So in the case that Farouk just mentioned, if there's a breach or some sort of security incident, that blast radius is a lot smaller at that point because those credentials have been immediately revoked.
And it's then using the AWS API calls to revoke them. Is that the way it works under the hood, or?
Yeah, so Vault is talking to AWS IAM through like the OIDC provider, but Vault is fundamentally the credential store holding the credential, the generated token. And so if the Vault agent says, hey, this TTL is up, it's time to expire this, Vault itself will revoke the token. And anywhere else, I think Farouk mentioned it'll still live in the context of STS, but as far as Vault is concerned, that credential is immediately revoked.
Right. So when it comes to all of this around secrets, of course, authentication and so on, I guess compliance is a topic we perhaps should touch on. So how does this work with compliance?
I can kind of touch on the Vault piece, and I'll let Farouk speak to, and maybe Sean can chime in on the actual the under the hood stuff that happens with the Kubernetes part. For compliance, Vault comes in two different flavors that I mentioned: open source and enterprise. And a lot of agencies in the public sector, a lot of commercial organizations as well, are potentially dealing with, how do we retroactively track who has contributed code to this code base, right? In the case of federal governments, is it a foreign actor, foreign developer, or is it a U.S.-based developer, for example? If it's a nation, or if it's a particular bad actor, I think we've all read about supply chain issues, especially within the software supply chain. And so where the open source version of Vault shines is being able to get up and running quickly with a secrets management solution, something like this, proof of concept. And once we move into actual enterprise use cases, enterprise utilization, where those compliance mandates are required, that's where Vault Enterprise comes in. So Vault Enterprise is FIPS 140-2 compliant, with and without an HSM, a hardware security module. That's been validated by our security partners, a third-party auditor, and that's really where the compliance piece focuses, is on the enterprise version.
Farouk, you want to touch on the EKS part of it?
Right. So yeah, this is where the integration between Vault and EKS, so in the form of Vault agent, comes in. So we haven't talked about credentials being encrypted, but there is a new feature that probably Sean and Jay can talk about. That there is a new feature that is being introduced where these credentials and credentials files and syncs could have the capability of doing public and private key-based encryption. So your credentials that are shared from the Vault agent to the microservice can be completely secure from that perspective. So for the purpose of demo and for the purpose of showing the solution, we have not gone into those complexities, but those are capabilities that are forthcoming in newer versions of Vault, and EKS completely supports those capabilities.
And I guess I want to highlight again, not necessarily compliance, but so Vault is an identity-based, centralized secrets management and broker, right? So it's all based on identity, which is very hard nowadays, right? We have so many different ways of authenticating, and that's what makes Vault very powerful, right? So we saw here we use app role. We actually have different methods. We have, so it really depends, but the dynamic nature of that, right? So there's times where onboarding and offboarding humans, onboarding and offboarding applications, onboarding and offboarding machines can be very difficult to track, especially in a timely manner. And Vault really helps with that, not just with restricting access, but with that sort of restriction as well.
I asked previously about EKS and EC2, but maybe we can just return to that, talk about this same pattern, but for I guess for other architectures and how this same pattern perhaps can be used. You said, Jay, that it was. Did you say that it was infrastructure agnostic, or what the term you used was?
Yeah, absolutely. So, we can think of it as infrastructure agnostic, platform agnostic.
Yeah.
Vault is written in the Go programming language, so it's very lightweight. It's just a binary, and it's supported with Linux, Mac OS, Windows operating systems, and any architectures out there, and even ARM 64-bit Raspberry Pis, for example. So.
Yeah, and similar to Kubernetes, right? So kubectl wraps API calls to the kube API. Same, Vault has a fully supported API. The Vault command line makes it easy to interact with it, but you can also call the API directly as long as you're able to authenticate again and send the proper token to it, so it can recognize that you have specific access or you're authorized to do so, right? So absolutely, any platform fully support, we have a well-documented API, so you could call those APIs direct. From, again, purposes for this demo, we're using, I guess we didn't use it here, but most of the time you'll see people interacting with Vault with the Vault CLI, but we have the API as well, and a interface. But if we're talking machine access, we're probably using CLI or API.
Right. All right.
Yeah,
go ahead.
This specific pattern that we talked about, the sidecar, is very specific to Kubernetes environments. But we could, modify a little bit and tweak it to serverless environments or environments where folks are running, for example, EC2 instances, and present a similar, I wouldn't say exactly the same, but similar sort of pattern.
All right, so we are approaching top of the hour, so I think it's time to start wrapping up. This is Building SaaS on AWS with me, Gunnar Girosh. I've been joined today by Farouk, a colleague from AWS, and Jay and Sean from Hashicorp. And we have been talking about dynamic data isolation with Hashicorp Vault on Amazon EKS. So do we have any great call to actions for our viewers out there? How do they go about trying this out? We've shared a blog post, of course, already, but what would be the next step then?
Yeah, I would suggest looking at the GitHub repos. We have shared 2 GitHub repos as part of the blog post. One is, based on Bash scripts, which essentially shows every single step, as you progress towards deploying the solution. And there is a great GitHub repo shared by Hashicorp, which demonstrates the power of Terraform in deploying the solution. So yeah, all viewers, everybody's welcome to try those, and we're open to feedback. Sure, share your feedback. Let us know how you feel about that. That'll be great to hear from the audience.
Great. Jay, Sean, how do people get started with Vault besides using the solution that's in the blog post, of course?
Great question. So in addition to the various links and assets that we've already provided, we at HashiCorp have a great resource library for developers. So it's developer.hashicorp.com. There's a bunch of hands-on tutorials that you can work at your own pace, from beginner use cases, Vault 101, over to some advanced use cases like we're seeing today with Vault agent sidecar injections into Kubernetes clusters, for example. There's also free hands-on workshops that we can hold for you. And then we have a great YouTube channel with a huge library of tutorials, walkthroughs, assets, based on what I just described, in case you're a visual learner as well.
That is great. All right. And with that, then, I want to thank my guests today, Farouk, Jay, Sean. Thank you very much for joining. I know it's early for some of you, so you have a long day ahead after this live stream. Also want to thank all of the viewers, and thank you to Anthony and Bill in the chat as well. And this has been another episode of Building SaaS on AWS. And we are, of course, back again in 2 weeks with a new episode. So thank you all very much for joining.
Thanks, everyone.
Thanks, everyone.
Yeah. Thank you.